Okay, so here we've got our two skaters. They've pushed off from each other, and I've done a few quick and dirty calculations. Okay, and so we wind up with this situation. Here's what's going to happen. Um, he's going to take off this way, all right, and she's going to take off this way. Their accelerations we already know are going to be different. She's got a negative acceleration going this way. He's got a positive acceleration going this way. And then what's going to happen here is I'm going to say that the duration of their collision, of their pushing off from each other, is 1.5 seconds. And I came up with a final velocity for him going to the right, and I came up with a final velocity for her going to the left. The magnitude of hers is greater. She's negative 2.5 meters per second, and he's positive 2 meters per second. Okay, so let's take a look. Let's take a look at what this means for conservation of momentum. All right, since we've got Newton's third law, forces are equal to each other, and now the net forces when they're all done. Well, okay, so when they're standing here, let me bring this back. When they're standing here, and then even when they separate, even when they take off and separate, the net forces on it, you got her, the earth pulling down on her like this, the normal force of the ice pushing up is equal to 0. There's no acceleration in the x direction anymore. So those forces go to 0. So the net forces add up to 0 in this case. All right? So now, here's what happens. So we say this. The conservation of momentum tells us this, that the conservation of momentum before is equal to the conservation of momentum after. All right, so I'll take M1, mass of the girl, before, so we're adding up the sums of all the momentums. So we're taking her momentum. Now, was she going before they even started? No, she wasn't going before they started. So 0 plus the mass of the boy times 0. This is all that's happening before is equal to the mass of the girl afterwards, her final velocity for the girl, plus mass of the boy afterwards and the final velocity of the boy. And guess what those, so we've got 0 before, so these two should add up to 0. These two should add up to 0. So here's what we'll do. Let's say that the mass of the girl, based on my quick and dirty calculations, I said that the final velocity of the girl sorry, I'm going to go ahead and finish this off here. And then, so let's say the final velocity of the girl is equal to negative 2.5 meters per second. Okay? What's the final velocity of the boy? What's his final velocity? Well, we can figure this out because we've got 0 is equal to her mass, which was 60 kilograms, times negative 2.5. This is her mass times her velocity, plus the mass of the boy, 75, times the final velocity of the boy. Well, we've got a bunch of numbers and only one unknown. I think we can do this. So let's just add this to the other side. So I take 60 times negative 2.5. So I get 60 times negative 2.5. And I get negative 150. Ooh, this is going to work out nice. Negative 150 newtons, or 150 kilograms meters per second. It's actually Newton seconds, plus 75 times VFB. Add negative 150 to both sides. So that goes away. Bye, Felicia. All right, and this is equal to 75 times VFB. So the final velocity of the boy is equal to 2.0 meters per second in the other way. Pretty cool. All right.